Okay, so now we're starting for the much awaited organic chemistry. सबने दिमाग खाया है organic कब शुरू करेंगे, organic कब शुरू करेंगे. So we're going to start with organic chemistry of +2 over here. This is unit 10, right? Now इसमें हम लोग जो कर रहे हैं, we are going to do haloalkanes and haloarenes. किस तरह से हम पूरा का पूरा जो हमारा लेक्चर है उसको हम कैसे प्रिपेयर करेंगे, इसमें आपको सबसे पहले we have to do the introduction कि haloalkanes और haloarenes कहाँ पे हमारे को यूज होते हैं. Then second में we will do the classification. Third में we will do the methods of preparation and then the physical and chemical properties of both. Right? Now when we are talking of haloalkanes and the haloarenes, we know that 11th में आपने करा है कि hydrocarbons जो होते हैं they are known as the parent compounds. क्यों इनको हम parent compounds बुलाते हैं? The reason behind is that from the hydrocarbons, by substituting the hydrogen by various different elements or group of atoms, we get different products. ठीक है? So that is why everything, all the organic compounds, they are going to be formed from hydrocarbons. That is the reason why they are known as parent compounds of all organic compounds. ठीक है? Now when we are talking of क्या कहते हैं उसको, haloalkanes and haloarenes over here, in this case it is said that the aliphatic substituted products, aliphatic substituted products, they are किसके substituted products है ये? Hydrocarbons के. They are going to be known as alkyl halides, which is generally the common name, or haloalkanes, which is the IUPAC name. For example, if CH4, that is going to be the hydrocarbon over here, तो इसका aliphatic substituted alkyl halide, that is going to be CH3Cl, where one of the hydrogen that is substituted by the halogen. Now more commonly or generally this will be written as CH3X, where X that is going to denote any halogen. ठीक है? फिर उसके बाद the aromatic substituted product, the aromatic substituted product, that is going to be known as what? That is known as aryl halide, right? और अगर IUPAC देखें, that is going to be known as haloarenes. Okay. Now when we are talking of haloalkanes, as I just said that the haloalkanes, they can be represented by Rx, where R is going to be the alkyl group and X that is going to be halogen. And the aromatic hydrocarbons, जैसे हमारे पास आ गया simplest one which we can have over here is X on the benzene ring, and this is going to be represented as ARX. ठीक है? Where AR that is going to be the aryl group and X is can be any halogen, fluorine, chlorine, bromine or iodine, right? फिर उसके बाद when we talking of haloalkanes, in case of haloalkanes, the carbon atom to which the halogen is attached, that is known as what? That is known as alpha carbon atom. In case of haloalkanes, we will see that the alpha carbon atom that is going to be sp3 hybridized. Okay? Alpha carbon atom is the carbon atom to which the halogen is going to be attached. So over here in haloalkanes, the hybridization of this carbon atom is going to be sp3. Whereas when we are talking of haloarenes, the hybridization over here that is going to be sp2 hybridized. So just come back to this over here. If this is the carbon atom to which the halogen is attached, this is going to be sp3 hybridized. Whereas यहाँ पे it is attached to the benzene ring, this carbon over here, this is going to be sp2 hybridized. Okay? So this is just a small introduction. Now when we are talking of halogen compounds, the compounds or hydrocarbons to which halogen is attached, they are of a lot of medicinal uses. For example, we have a medicine by the name of chloroamphenicol. This medicine has chlorine as a substituent in organic compound, and this is used for treatment of typhoid fever, right? Or for the treatment of typhoid. Then you also know that there is one hormone which is secreted that is thyroxine. This is an iodine containing hormone. This is an iodine containing hormone, deficiency of which is going to cause a disease which is known as goiter. ठीक है? So TSH इसको हम लोग बोलते हैं थायराइड स्टिमुलेटिंग हार्मोन. तो अगर उसकी या तो ज्यादा हो जाए सिक्रीशन या कम हो जाए, अगर ज्यादा होती है तो उसको हम हाइपरथायरॉइडिज्म बुलाते हैं, और अगर कम होती है तो हम उसको हाइपोथायरॉइडिज्म बुलाते हैं, right? So in this case this also contains iodine. Then we have another medicine which is chloroquine. Chloroquine again contains chlorine, and this is used in the treatment of malaria. Okay? Now apart from these, you already know about one kind of compounds which are known as chlorofluorocarbons. Now these chlorofluorocarbons, these are generally hazardous to the environment, as they are one of the major culprits in depleting the ozone layer, and they are generally found in refrigerants and ACs. Okay? Then there is another chlorofluorocarbon which is used in surgery as an anesthetic, which is right. So this is going to be what? How will you name it? This is going to be, सबसे पहले क्या आएगा? B. So this is going to be 1 bromo, 1 chloro, 2 trifluoroethane. ठीक है? So this is used in surgery as anesthetic. Okay? So this is what we have. This is just a small introduction which we are going to do over here. Let's go on to the main topic, classification of halogen derivatives. Now when we are doing the classification of halogen derivatives or classification of haloalkanes, let's say how are we going to classify it? The halogen derivatives they can be classified into aliphatic halogen compounds, and aromatic halogen compounds. This is the broad classification of halogen derivatives of hydrocarbons. So this is aliphatic, and then we have aromatic. In case of aliphatic halogen compounds, they may be further classified into haloalkanes. Haloalkanes means that there is going to be carbon-carbon single bond over here. So certain examples which we can do over here is bromomethane, chloroethane, or iodoethane, right? Second, that is going to be haloalkenes. Haloalkenes of the type which has a carbon-carbon double bond. Okay, so this is going to be known as 1-chloroethene, right? Then we have haloalkanes. Haloalkanes, they are going to have a triple bond over here. So we have C triple bond C Cl. This will be known as 1-chloroethene. So this is how we are going to broadly classify the aliphatic. Aromatic, they are classified as nuclear halogen derivatives and side chain derivatives. Nuclear halogen means that the halogen that is going to be directly attached to the benzene ring. So over here, examples which we can take is simple ones. We have bromobenzene, or we have orthochlorotoluene, right? So these are going to be some of the examples of nuclear derivatives. Then the second one which we have is side chain halogen derivatives. So side chain halogen derivatives में the halogen is not directly attached to the benzene ring, but it is attached to the side chain. This is known as, if you're looking at the common name, this is known as benzyl chloride. ठीक है? This is going to be known as benzyl chloride. और अगर हम इसका IUPAC नेम लें तो this is going to be phenyl chloromethane. Okay, so this is how we are going to broadly classify. Then we have classification on certain other criteria also apart from what we have done over here. So let's just take a look at the classification again. Now there are going to be a lot of factors on the basis of which हम लोग classify करेंगे. The first factor, that is type of halogen atom. So depending upon type of halogen atom, we have the first one which is fluorobenzene. Okay, so उसी तरह से अगर आपके पास फ्लोरीन की जगह क्लोरीन है, so this is going to be chlorobenzene. Then we have bromobenzene and so on, right? So depending upon कौन सा halogen है, उसके basis पे we can classify them into fluoro, chloro, bromo and iodo derivatives, right? Then number 2 we have on the basis of number of halogen atoms. On the basis of number of halogen atoms, we can classify them into mono halogen derivatives. Mono halogen derivatives means mono means one. So there is going to be only one halogen which is going to be present. So if you have CH3, CH2Br, this is going to be bromoethane. Or if you have Cl on a benzene ring, so it is going to be chlorobenzene. The second type which we have, they are known as dihalogen derivatives. The dihalogen derivatives, they are further classified into two types. One which are known as gem dihalides. Gem dihalides means when the halogen that is attached to the same carbon atom, both the halogens in this case, they they will be attached to the same carbon atom. जैसे हमारे पास आ गया CH3, CH2, CH, Cl and Cl. This is 1,1 dichloropropane. Okay, so these are known as gem dihalides when they are going to be attached to the same carbon atom. The second one which we have over here, they are known as vicinal dihalides. Vicinal dihalides means when the halogens they are attached to two different carbon atoms, but those carbon atoms should be adjacent. ठीक है, जैसे for example if we have CH3, CH, Cl and CH2, Cl, तो this is vicinal dihalide. अगर एक हेलोजन यहाँ पे और एक हेलोजन यहाँ पे आ जाएगा, then that is not vicinal. Vicinal means that they are attached at the adjacent carbon atoms. So what is going to be the name of this compound? 1,2-dichloropropane, right? Then we have polyhalogen derivatives. Polyhalogen derivatives means what? That they are going to be more than two halogens present. They may be tri. Tri means 3. They may be tetra. Tetra means 4. So tri over here, one example in which all the halogens they are attached to the same carbon atom, that is CHCl3. This is more commonly known as chloroform. ठीक है, और it may be CH2Cl, CHCl and CH2Cl. This is going to be 1,2,3 trichloropropane, right? Or we have all the three halogens attached to the benzene ring. So this is all trihalogen derivatives. Then tetrahalogen derivatives may be CCl4, carbon tetrachloride, which is very commonly used as an organic solvent. Okay, so this is one classification depending upon the number of halogens which is present. The third classification is nature of carbon atoms. The third classification which we are going to do over here, that is nature of carbon atoms, right? This is very important because ये आपकी nature of carbon atoms that is going to be present in all kinds of classification, right? और इसी के basis पे हम लोग जो trend study करेंगे इसमें वो इसी classification के basis पे करेंगे. So you should recognize, you should know how to recognize the primary, secondary and tertiary kind of carbon atoms over here. Okay. The first one which we are going to do is primary haloalkanes, and they are also known as 1-degree haloalkanes. Now this primary carbon atom or 1-degree carbon atom is that carbon atom to which one or none carbon atom is attached. ठीक है, so that carbon atom to which either one or none carbon atom is attached, that is going to be primary. An example which we can take over here is CH3, C, H, H and Br. So if you're looking at this carbon atom over here, this is going to be 1-degree carbon atom because इसके साथ only one another carbon atom that is going to be present. So this is the carbon atom which is going to be 1 degree. ठीक है, second जो हमारे पास आता है that is known as secondary carbon atom, or it is more predominantly known as 2-degree carbon atom. In this case, to that carbon atom to which two other carbon atoms are attached. Okay, so there are going to be two other carbon atoms. An example which we can take over here, we have CH3, C, CH3, H and Br. So if you're looking at this carbon atom over here, we have one carbon atom and two carbon atoms attached. So So this is going to be a 2 degree carbon atom. ठीक है? फिर उसके बाद हमारे पास आता है tertiary haloalkanes और 3 degree haloalkanes. Tertiary haloalkanes or 3 degree haloalkanes. It is that carbon atom to which 3 other carbon atoms are attached. To which 3 other carbon atoms they are going to be attached, that is tertiary. So tertiary is going to be represented as this is going to be the tertiary carbon atom, or it is more commonly known as 3 degree carbon atom. ठीक है? So this is the third classification which we have done. The fourth classification we will do on the basis of the hybridization of the alpha carbon atom. ठीक है? So that is the fourth classification. The fourth classification that is going to be based on hybridization of alpha carbon atom. So over here we have compounds containing sp3 hybridized alpha carbon atom, right? The first one in this category, they are the normal haloalkanes. Normal haloalkanes means we have CH3, CH2, Br. So this is the alpha carbon atom, and the hybridization that is going to be sp3. Okay? Then these are also known as alkyl halides. So अगर आप cyclic भी ले रहे हो for that matter, if you have a compound like this is also going to be haloalkane, chlorocyclopropane. ठीक है? Is it clear? So similarly, if you have another longer chain which you want to take, CH3, CH2, CH2, Br. So this is the alpha carbon atom, which is again going to be sp3 hybridized. Okay? The second one which come in this category, they are the allylic halides. In case of allylic halides, the alpha carbon atom that is going to be sp3 hybridized, but the beta carbon atom that is going to be sp2 hybridized. Okay? An example which we can take over here is CH2 double bond CH, CH2 Cl. So you can see over here that the alpha carbon atom is sp3 hybridized, but the beta carbon atom over here that is going to be sp2 hybridized. Right? And what is going to be the name? 3 chloropropene. Because यहाँ पे numbering हम यहाँ से शुरू करेंगे, we give preference to the double bond rather than the substituent. So this is going to be 3 chloropropene. ठीक है? फिर उसके बाद the next one which we have, that is going to be benzylic halides. Benzylic halides. In case of benzylic halides also, we will see that the alpha carbon atom that is going to be sp3 hybridized, and the beta carbon atom that is sp2. So this is the alpha carbon atom and this is going to be the beta carbon atom. So alpha carbon atom is sp3 hybridized and beta carbon atom that is going to be sp2 hybridized. ठीक है? फिर उसके बाद the second classification or the second type of haloalkanes which we have over here, in which the alpha carbon atom that is going to be sp2 hybridized. The first example in this case we have is that of vinylic halides. Now over here we will see that the alpha carbon atom that is going to be sp2 hybridized. The example which we can take over here is that of CH2 double bond CHCl. This is known as vinyl chloride. Okay, but the IUPAC name is going to be chloroethene. This is commonly known as vinyl chloride, right? But the IUPAC name, that is going to be chloroethene. Then we have one halocyclohexene. One halocyclohexene. This is also a vinyl halide. Okay. The second one in this, they are going to be aryl halides. So when we are talking of D over here, this is going to be aryl halides, where the halogen is directly attached to the benzene ring. This is an example of aryl halide over here. Okay? Then the third is compounds containing sp hybridized carbon atom. Compounds containing sp hybridized carbon atom. In this case, the alpha carbon atom is going to be sp hybridized. So you have an example over here, CH triple bond CCl. Okay, this is known as chloroethine. Okay, so this is how we are going to do the classification. The next topic which we are going to discuss, that is the nomenclature of haloalkanes and haloarenes. Now when we are doing the nomenclature, you have to follow all the rules of nomenclature which you have done in your class 11. Okay? तो सारे के सारे वो रूल्स जो है उनको हम फॉलो करते हैं. जैसे फॉर एग्जांपल हम सिंपलेस्ट अगर कंपाउंड लेते हैं CH3Cl, दिस इज गोइंग टू बी क्लोरोमीथेन. सो वो सारे रूल्स, अदरवाइज पेरेंट चेन कौन सी लेंगे हम, जो लॉन्गेस्ट चेन होती है दैट इज सिलेक्टेड एज द पेरेंट चेन. ठीक है, देन यू आर गोइंग टू टेक द लोएस्ट लोकेट रूल. इफ देयर आर मोर देन वन halogens which are present, तो चेन की नंबरिंग वहां से शुरू होगी जहां से they are getting the lowest position. ठीक है, now these are taken as substituents. So इनको जो हम preference देते हैं that is going to be the last preference. Okay, if in case there's a, as you just saw कि अगर double bond present है और एक halogen present है, तो आप नंबरिंग वहां से शुरू करोगे जहां पे double bond को lower करेगा, right? If there are the same kind of halogens which are present, so you use the prefix di, tri, tetra and so on. If there are different types of halogens present, then you name alphabetically. So सबसे पहले आपका ब्रोमो आता है, फिर क्लोरो आता है, फिर फ्लोरो आता है और फिर आयोडो आता है. So if there are more than one that is present, so this is how you are going to do it. Then also if the halogens they are present at different numbers, you need to specify each number. जैसे 1 हो गया, 2 हो गया, 3 हो गया, तो कौन से numbers पे वो present है उन सबको भी आपने क्या कहते हैं उसको mention करना है. ठीक है. Now if there are, as I just told you, if there are 2 halogens of the same kind present, so then you have to mention the number and the prefix di, tri, tetra and so on. जैसे for example, if we have CH3, CL, CH, CH, Cl and CH3. So there are 2 halogens present over here. 1, 2, 3, 4. This is how you are going to number. So this is going to be 2, 3 dichlorobutane. So this is how you are going to name it. ठीक है? And if we have it, क्या कहते हैं उसको? If we have different kinds, जैसे हमारे पास आ गया CH3, CH, we have Br over here, then we have CH, Cl over here, and CH3. So यहाँ पे this is 1, 2, 3, and 4. So it is 2 bromo, 3 chlorobutane. Okay? So इस तरह से आपने इसकी naming करनी है. Now if we have 3 present, 3, then the word used, the prefix used, that is going to be tri. If there are 4 of same kind present, then it is going to be known as tetra. Now when you are naming the haloarenes, so haloarenes, they are going to be more commonly named as the name of the halogen first and then benzene. So this is going to be known as chlorobenzene. If there are 2 present, so So you need to mention the number over here. It is going to be 1,2-dichlorobenzene, right? Similarly, if there are 3 present, then again you are going to mention the name. अगर इसके साथ हमारे पास कोई और major functional group present है, जैसे CH3 present है, then this will be known as 2-chlorotoluene, right? Because CH3 group जो present होता है, then that is going to be known as toluene. Yeah, if we have another important functional group present over here, OH and chlorine, so this is going to be 2-chloro-phenol, right? So this is what we have over here. This is how you're going to name the haloarenes. Then next we have isomerism in haloalkanes and haloarenes. Isomerism in haloalkanes and haloarenes. Basically, they show 2 types of isomerism. The first one, which is chain isomerism. You know what isomers are. Those which have the same molecular formula but different structural formula, they are going to be known as isomers. So in chain isomerism, the molecular formula that is going to be same, but the chain that is going to be different. Okay? So an example which we can take over here is 1-bromobutane, ठीक है? और इसका अगर हम आइसोमर बनाएं, then this is going to be 1-bromo-2-methyl-propane. इसका एक और आइसोमर बन सकता है right? So this is going to be 2-methyl-2-bromo-propane. या 2-bromo-2-methyl-propane, right? Because आपको alphabetically name करना है. अब देखो यहाँ पे ये वाला जो कार्बन एटम है, that is going to be 1 degree. यहाँ पे ये वाला जो कार्बन है, that is also 1 degree. But if you're talking of the carbon atom over here, that is going to be 3 degree. ठीक है? Second type of isomerism which we have over here, that is position isomerism. Position isomerism में the position of the halogen that is going to change. For example, if we have CH3, CH2, CH2I, this is 1-iodo-propane. So if the position of iodine will change, we will have CH3, CHI and CH3. This is going to be 2-iodo-propane. Okay? So the position of the halogen that is going to change. Or if we have chlorine and chlorine over here, this is going to be 1,2-dichlorobenzene, right? So if the position of chlorine changes from here, this is going to be 1,4-dichlorobenzene. Still we can make another isomer over here, which is 1,3-dichlorobenzene, right? So this is going to be the position isomerism. Yeah, that clear हो गया? Okay, so today we will do only till here. Okay.